Welcome to the Smithville, Texas Eco Photo Festival 2021 webinar series. I'm Jill Struby, the past chair of the Smithville Area Chamber of Commerce and one of the founders of the EcoFest back a long time ago when it was the Smithville Green Expo. Both the Texas Photo Festival and EcoFest have been a tradition in Smithville for over 10 years. We are continuing to make the connections between eco and photo, and this is our second year using this virtual format for these interesting and important presentations. Our gratitude goes to you, the viewer, and your interest in these topics. This year, our theme is habitat, and we have asked experts in the ecological world and in the world of photography to help us dive deeper into the habitats all around us. Today's presenter is Bryan Hummel, who will be talking about nature-based solutions for enhanced resilience in Central Texas. Bryan is a Central Texas native and a biologist by birth. He worked as a park specialist for Bastrop State Park immediately after graduate school, and has incorporated nature-based green infrastructure practices into several habitat regeneration projects across private, state, and federal lands. Nature-based principles often improve the health of the ecosystem and convert flooding liabilities into agricultural abundance and groundwater assets. His focus is on teaming with nature to benefit people, planet, and profits. And Bryan, I really like that play on words. You've got it teaming as in we are a team, T-E-A-M, but teaming with nature, T-E-M, is really fantastic way to bring all that abundance to life. Bryan, we are so glad you're able to join us today. Thank you for being here, and thanks for all your work in the field. I'm really looking forward to this presentation, and I'm turning it over to you.
Excellent. Well, thank you for having me. I am going to try to pull this slide presentation up. And one more time. Excellent. So are you seeing the first page?
Yes, it looks perfectly, it's perfect. Thank you.
Excellent. Okay, so again, thank you for inviting me to present at this Photo Eco Fest. I'm going to again talk about nature-based solutions. We're going to try to cover a lot of topics fairly quickly. We're going to start very broad scale on a national scale, talk about some water issues, then hone down to Texas, and then get even more specific to the Colorado River scale. I also plan to be available for the live question and answer session that's coming up in a few weeks. So we get rain, and typically we get more rain in the east and less rain in the west. Sometimes we don't get enough rain, and you can see this with the drought monitor. Luckily, we've been having a fair amount of rain this year, and Texas is not covered up in the red stage of drought like we have been many times before. Other times we get a tremendous amount of rain. So Hurricane Harvey brought a lot of rain in 2017, and at approximately 27,000 gallons per acre inch, this storm dropped over 20 trillion gallons of water across Texas. That's enough water to cover every acre of Texas with about 4.5 inches of rain. So remember that number, the 4.5 inches of rain. If it were evenly distributed across all 172 million acres of Texas, that's approximately how much water Harvey brought. And there's ways that we can turn that water into an asset instead of it being a massive flooding liability. Here's the track of tropical cyclones. So as you can see, the Gulf Coast gets hit pretty regularly, and a lot of times that brings us, large volumes of rain. But it doesn't even have to be hurricanes. Tropical storms have brought just astronomical volumes of rain to our region. In 1978, Tropical Storm Amelia brought 48 inches of rain to Medina, Texas, and up in Abilene, all the way up in Abilene, 26 inches of rain fell in a 12-hour period. So that's much more rain than a typical landscape and typical soils can absorb. A lot of that rainfall volume runs off and contributes to a flooding liability, and a lot of that landed in the Colorado River Basin and is working its way down towards Smithville. So when water comes out of the sky, it can only go three places. It can go up, it can evaporate, it can run off, or it can infiltrate down. And you see that with the water cycle. And I think people have a fairly good grasp of what happens when the water runs off because of our rivers. We can see them, we can kayak down them. We have a pretty good understanding of rivers. I think we understand less about our groundwater systems. However, there's groundwater systems, and in some cases they're like underground lakes, in some cases they're like underground rivers, and they occur under a good majority of the entire United States and a good majority of Texas as well. So what influences whether the water runs off, soaks in, or evaporates? And that's really how we manage our land. So a lot of people have seen this graph, and I will try to be fancy here and show a laser pointer. Oh, there we go. So in a natural condition, more of it infiltrates, relatively little runs off, and you have some decent evaporation from all the trees. As you get more and more developed, you get more impervious cover, less infiltrates, and more runs off. And that's where you end up having, when you start getting more urbanized, you start having more flooding problems because the water just can't soak into the ground as readily as it can under natural conditions. However, urban environments are not a majority of the land. Here is a Bloomberg study. I want to highlight here, anywhere I use air quotes or quotes around a title, if you search for that, it should bring up the study that I'm talking about fairly quickly. Also, in several cases, I put in the web address. So Bloomberg did a study. They looked at each one of these squares covers about 250,000 acres. They found the dominant land use for each pixel, and then that sort of shows you the distribution of where forests are, where cities are, where cropland is, where grazing land is, and so forth. And then they smashed all of those items together and came up with what is basically the average watershed in the United States. About 35% of the United States is under some sort of grazing regime, about 28% is under forestry, 20% is under crops. So basically 75 to 80% of our land mass is under agriculture. And right now, only about 4% of our land is what they would consider urban. So when we're trying to do things like improve habitat and or mitigate flooding or turn flooding liabilities into groundwater assets, I'm going to spend 80% of my time talking about the agricultural sector because that covers 80% of our, give or take 75, 80% of our nation's terrestrial landmass. So if you go back, I asked a couple of questions, and I promise this is my most wordy slide, but how did nature manage these lands before Europeans got here, even before Native Americans got here? How can teaming with nature benefit us today? How can we mitigate the various risks that we have within each land use? And how can we tap into current funding opportunities for nature-based mitigation and resilience? So bison managed most of North America's grasslands and shrublands. Even they had a woodland bison that went into many more forested areas. But unfortunately, the bison were hunted to near extinction by about the 1880s, with their population dropping from about 30 million bison down to just around 1,000 animals. And beaver managed our lowlands and waterways. But again, our beaver population went from maybe 400 million beaver down to just a handful in the most remote areas. And then when the beaver populations dropped so dramatically, it's estimated that over 250 million beaver dams were eventually degraded. We lost approximately 235,000 square miles of impounded water. That's enough water and wetlands to cover 87% of Texas with wetlands, if you're looking at a national scale. So it's not that Texas was 87% underwater, but that's just the scope of the landscape degradation and the habitat degradation that happened when we removed, give or take 400 million beavers. I want to highlight here, there is an amazing 20-minute natural history lesson on the beaver with Ben Goldfarb at this link. It's definitely worth your time, and a presentation that's by far better than what you're going to see from me today. Let's also talk about beaver. So these beavers provide these little wetland corridors, especially in drier environments, and basically they provide these emerald refuges from drought or wildfire. So another great presentation is Smokey the Beaver by Emily Fairfax. There's like a 42-minute stop motion animation, which is amazing. And basically water doesn't burn. So if you have a wildfire, these riparian corridors stay nice and green because they're just so moist that the plants don't burn. And then after a wildfire, the sediments and the ash and the charcoal and stuff that wants to wash downstream, instead of beelining it down the river and filling up our lakes and going out into the Gulf of Mexico, it is actually captured by some of this riparian vegetation that Kevin Anderson did a great job discussing last year. I'm going to discuss a little bit more in this presentation. But, beavers can help mitigate flooding and drought and wildfire all concurrently, and they do it for virtually free. It's basically they work for sticks. And then on our agricultural lands, there's basically 5 principles of agriculture that are nature-based principles. They're supported by the U.S. Department of Agriculture, all sorts of farming groups, the carbon sequestration industry, as well as the regenerative ag folks. And that is, do the least amount of disturbance possible on your land. Leave a living root in the ground as much as you possibly can. Leave armor on the soil, whether that's mulching a garden or a community garden or a backyard garden, or leaving the crop residue on tens of thousands of acres as they harvest their corn or soybeans. Animal integration is really key. There's really no ecosystem on Earth that doesn't have animals in it. And even in cropland systems, there's tons of animals. You're just not seeing them because they're below the soil surface. And you want to have increased biodiversity. So either do a really good job rotating your crops or plant multiple species at the same time. And there's some real experts in this field that I'm going to highlight here in just a second. Probably one of my heroes and one of the best, 17 minutes on regenerative agriculture you can possibly find on the internet. You can find if you look for Gabe Brown TED Talk. So on this Brown farm, which is in North Dakota, but these practices and principles work pretty much everywhere across the globe. They're farming in nature's way. They're using very few chemicals. They're making more money per acre. And if you look at this bottom little section, if you do those principles of soil health, you can absorb more carbon dioxide into your soil. You could build your soil organic matter, and that soil organic matter helps you hold more water and turn that rainfall into an agricultural asset. If you leave your soil bare, the carbon in the soil gets basically attacked by oxygen and turns into carbon dioxide and floats away. So soils that are heavily tilled are oftentimes losing carbon dioxide and losing water to the landscape, and that is turning them into basically flooding liabilities, where if you focus on your soil health, you can turn your land into sponges. Here's a national case study, banking on soil health. They found that farmers that focused on soil health had an average yield bump by 12%. Their average return on investment was 176%. These farms increased infiltration. They reduced their water runoff. They had less soil erosion, and that led to better water quality outcomes. If you want to find a Texas example, a little bit north of the Colorado Basin, up near Henrietta, Texas, northwest of Fort Worth, you can look up herd impact, or you can go to carboncowboys.org and you can see this farm. It's the Birdwell Clark Ranch. They've won the Texas Lone Star Land Stewardship Award. They've also won National Environmental Stewardship Awards. And they basically took their cows and they hunched them up like the bison did. And they have one big herd of over 5,000 cows, but they move them at least once a day. There's an amazing video that they talk about how they've moved their herd in the last 10, 15 years. And when they started on this one parcel of land, there was a lot of bare ground back in 2014, and now it's almost totally covered in grass. And we're going to talk about the benefits of that coming up as well. A little bit north of us as well is the Emmons Farm in Oklahoma. They're winning the Leopold Conservation Award. They're getting awards from the U.S. Department of Agriculture. And I love this right up in this like 6-minute video that talks about how the Emmons land stewardship changes have helped increase infiltrations by over 1,200%. When they first started on this soil health venture, they could only absorb about 1/2 inch of rainfall per hour. And after doing some of those principles of soil health, they're now over 6 inches an hour, in many cases over 7 inches an hour of infiltration on their land. So again, they're converting a flooding liability into an agricultural asset, and they're recharging these soil sponges that we know are so important, that help feed our river during times of drought. So how does all this water work, and what kind of boundaries does it follow? And I'll tell you that it doesn't really follow county boundaries. This is a map of all of the COGs, the councils of government across the state of Texas. Water definitely doesn't follow our congressional boundaries, which are about to change again anyway. They follow our geology and our topography and our watersheds and our river basins. So I want to highlight here a couple of Central Texas river basins. One of the larger ones is the Colorado River. It covers 42,000 square miles. I believe that's 27 million acres. And now just a little bit of math, because both of my parents are mathematicians. If you divide 27 million acres by 12, you get how many acre feet 1 inch of water across that whole area would be. And you come up with 2.256 million acre feet of rain. And what that ends up meaning is that if just 2.5 inches of rain in this big area is more water than all 31 reservoirs in the Colorado River Basin, going from totally empty to totally full. So if we could catch that Hurricane Harvey and put it right in the Colorado River Basin, it would fill all of our rivers up multiple times over. And even in smaller rain events, if it was perfect conveyance, just 2.5 inches of rain in the Colorado River Basin would fill up all of our rivers. Fill up all of our rivers and all 31 reservoirs. But let me take a step back. If 2.5 inches of rain can fill up all of our reservoirs, assuming perfect conveyance, like no water soaks into the ground, then if we can soak up an additional 2.5 inches of rain into this entire area, that 2.5 inches of rain still represents as much water as all 31 reservoirs put together, but now we're soaking that water up as an agricultural asset instead of a flooding liability. And if you don't want to believe me on some of these numbers, they all came from the Texas Water Development Board. So here's a list of all 31 reservoirs. Here is some size in volume, how much each of those reservoirs can hold, and that in acre feet. And I went ahead and I did a big math spreadsheet. So you guys can go ahead and double check my math if you're interested in. But let me tell you that just a little bit of infiltration makes an enormous difference to the rivers. If you want to learn more about rivers, this is a guide from the Nueces River Authority. I highly recommend it, this You're Remarkable Riparian. I know Kevin Anderson gave just a phenomenal talk at last year's Photo Eco Fest, and he also thinks this is a good document. There's some other great information at texasriparian.org, I believe. But because you can go back to see last year's talks on, more specifics of the river, I'm going to let you go watch that other presentation, because Kevin did a better job than I did anyway. So I'm going to talk about land management strategies and how we can use nature-based solutions to help keep our rivers clean and help mitigate our communities from flooding and drought liabilities. So how often do you see bare exposed soil in nature? When I'm walking in the woods, whether it's a forest or a prairie or a grassland or a savanna, I mean, pretty much anywhere except the driest of environments or environments like the beach that are being hammered by waves constantly, I rarely see exposed soil. However, in agriculture, I see exposed soil all the time. How many of you guys see people plant their rows of crops basically going up the hill? And when you do that, what happens is each little row basically makes this little channel to invite water to leave your landscape as fast as possible. And when that happens and you get enough rain, that water leaving creates basically a funnel to help soil and water leave your property as fast as possible. So I want to ask a question here for people that know anything about, plants, which probably everybody on the planet. What are the 4 things that plants need to survive and thrive? And because I don't have an audience today, I'll just go ahead and tell you. They need sunlight, they need water, they need good soil, and they need carbon dioxide or oxygen in the atmosphere. So out of those 4 things that plants need to survive and thrive, The sun comes up every morning. You know, we don't have a lack of sunshine in most cases. We don't have a lack of CO2 in the atmosphere. In fact, in some cases, there's more than we need. The two limiting ingredients to unlock the growth potential and therefore the profit potential of almost every property and the habitat potential and ecosystem service potential, the two main ingredients, the two most important ingredients are the quality and quantity of your soil and the quantity and timing of your rain. So things that you do on property to help rush water and soil off your property are degrading, and things that you can do to slow it, spread it, sink it, soak it, and store it onto your landscape are regenerative and help your land become healthier, help your habitat become healthier over time, and help your rivers become healthier over time. So if you have a lot of lands where a lot of the water is rushing off very quickly, that leads to flooding. Here's this is right outside of Blanco, Texas. This is Highway 165 bridge and some flooding they had in 2015, where the river got about 45 feet deep for about 45 minutes. Here's the Fisher Store Bridge. Again, 45 feet deep flow for a little bit over 45 minutes. You know, how much do you think one of these bridge section weighs? It weighs a lot. How much force do you think it would take to pick up one of those bridge sections and throw it downstream by several hundred feet? It takes a lot of power. So there's tremendous power in those floods, and building the bridges back better and building more flood control dams doesn't really address the root cause of the problem. The root cause of the problem is too many gallons of water flowing off too many acres too quickly, and that becomes under our control. So land stewardship makes a big difference. You can see these fence line comparisons almost everywhere you go. One side of the fence, you've got big, beautiful grass. The other side of the fence, you have almost no grass or bare dirt or grass that's only an inch tall. And there's funding for helping make the lands healthier. For example, there's a RCPP program from the USDA. The Audubon Conservation Group just got $3.25 million, and they're trying to help restore 2.5 million acres of land. And they're already working with ranches across the state of Texas. And by improving those ranches for birds and for grassland, it's going to help improve the rivers too. Here is another example. This one's actually a little bit south of us down in Chihuahua, Mexico, but this is just 3 miles away, the same exact day, just 3 miles away. In one area, the land management, where it's continuous grazing, every cow, any green blade of grass, the cow comes and eats, and you're left with a desert. In another area, they actually have twice the stocking rate, and but they moved them like the bison, and the desert returned back to a healthy grassland. And we've known for a long time, and certainly we've done research on it since the 40s, that if you constantly are grazing your grass really, really short, you have a relatively small root system. You let your grass grow a little bit longer, you get a better, bigger root system. But to really get this massive root system underground, which is what you need to help build your soil health, you need to occasionally let your grass get big and tall, because the amount of biomass and the amount of habitat above the Earth's surface is highly correlated to the amount of biomass and biology below the Earth's surface. The other thing I want to say is, as you then come back and graze the healthy grass off, a lot of those roots die back, and those dead roots provide little channels, like tiny little straw holes into the ground to help the water get into your upland landscape. And that's going to help your rivers. It's going to help mitigate the flooding during times of flooding, and it's going to help mitigate drought when the rains are not there. And again, this is just a great little documentation. If you cut the turf grass super, super short, its roots are tiny, but all of these native plants that are great for pollinators and great for butterflies and great for habitat and great for all of the native animals of Texas, what you see above ground is only half the story. What's below ground is just incredible, but most people don't see that. So I'm trying to highlight how amazing the roots are. And here are some root systems that just show that there's a tremendous amount of life happening below ground. In fact, some researchers now say that on every acre of land, you have enough life in healthy soil, you have enough life per acre to equivalent to African elephants in size. And you need to feed that biology. And the way you feed that biology is by following the soil health principles and letting the the grasses take sunlight energy and put it into a sugar form and pump it down into the ground to feed those microbes. There's tons of funding for this, both from the private sector and the NRCS. The NRCS and the USDA have cost share programs that absolutely help rivers and help water quality. They promote things like cover crops and filter strips and riparian buffers. They do a lot with contour farming and conservation tillage. They also have a bunch of really amazing demonstrations that you can see that do rainfall simulators, and they look at the different types of agriculture, whether it's high tillage agriculture or planting some cover crops or leaving the crop residue or having tall grasses in your pastures versus short grass in your pastures. And the rainfall simulator, I'm just going to barely touch on this. I highly recommend people to just search for that. And there's tons of videos online. They're great. But in the videos will tell you this. Out front basically represents runoff, and the buckets behind represent infiltration. So in areas that are highly tilled and don't have vegetation on, you can see how much water, so much water ran off that it actually didn't even make it in the bucket. It just exploded all over the ground. You didn't get that much infiltration. In areas where you have good cover crops, most of the water infiltrates. And then if you have thick grasses on your pasture, you get very little runoff. And what you do get runoff is clean versus, muddy, but you get a lot of infiltration. And again, these practices, what we do on the 172 million acres of Texas, radically influences our water quality and our drinking water and our recreation and our economy and everything else that involves around water. And if you don't believe me, here's a great picture from Austin, Texas. This is October 2018. This is when I'm sure you guys were having flooding down in Smithville. This is when Austin, this river was so brown and muddy and full of dirt and nutrients that their water treatment plant couldn't filter the sediment out fast enough to supply water to the city of Austin. They had to have a boil water notice. While at the exact same time, Barton Springs flowing into it's virtually crystal clear. The difference is basically how we manage the land and how nature manages the land. In the Barton Springs example, instead of the water rushing off and carrying that soil and water with it to contribute to a muddy brown flood, it soaked into the ground and came out as crystal clear spring flow. In other areas where we're not doing maybe the best land stewardship practices, our soil and our water are rushing off. It's carrying nutrients away with it. You get this muddy brown water. That muddy brown water full of nutrients causes algae blooms that nobody really likes except this guy. And so he looks like he's having a great time in, this is actually some big algae bloom in China, but we've had algae blooms like that even recently. And some of those algae blooms are toxic to all sorts of animals. So if we think about the difference between flooding and groundwater, I want to highlight that our water resources are just so incredibly valuable in the entire planet. I mean, water is life. But here in Texas, there's examples, including Smithville. Smithville was founded because of the river. If you look at a lot of the old cities throughout, the older cities and communities throughout the state, many of them in Central Texas were founded at these spring sites. These are all these different springs and all the communities that are popping up right at the springs. And it's definitely not a coincidence. So how can we help use nature-based practices to turn some of these flooding liabilities into groundwater assets? Anybody that pays attention when you walk around outside after a big rain are going to see these little squiggles all across the landscape. I call these micro detritus berms, and these micro detritus berms help slow, spread, sink, soak, and store water in the landscape. If you look at them, they occur in a series and a pattern over and over again. So if this one breaks, there's one down here to catch it. And if that one breaks, there's another one down there to catch it. So this redundancy, this repeating pattern and this redundancy helps build resilience, because if any one system fails, there's lots of other systems downstream to catch it. And that's exactly what beaver do. So again, as water moves across your screen, you can see that just like the microdetritus berms, beavers help slow, spread, sink, soak, and store water, but they do these mega detritus berms that help spread the water out. There's more now surface area and a connection point between water and land, more area for the water to soak in and recharge that riparian sponge. It's habitat, it's amazing habitat, it's flood mitigation, and it's groundwater recharge all at the same time. Unfortunately, several 100 million beaver were removed from the United States, and we're still suffering the economic and ecological consequences of that. But beaver are making a return, and even in areas where it's not likely to for beaver to return anytime soon. This USDA RCPP program is doing things that help fund beaver type practices. I will tell you that several of these have been awarded to groups in Texas, including the Hill Country Conservancy, and they're working from Onion Creek up to I think the Llano River, if not a river or two above the Llano. But anyway, all of those, all the area that their $5 million of land protection and improving the quality of land, all of that's helping improve water quality for you guys down there in Smithville. And I won't spend too much time on this, but they're managing a project to turn flooding liabilities into biologically filtered groundwater assets. And they're using basically juniper beaver dams, juniper chip wattles, and they're trying to enhance aquifer recharge. They're also doing it for wildfire mitigation. So as they trim some of the branches up in the watershed, that's where they get the material to make these little beaver dams to help catch the water before it makes it to the river. You can also use these same beaver biomimicry practices after a wildfire. So this is in 2011. This is in Spicewood, Texas. When Bastrop was on fire, there was other wildfires going on that maybe weren't quite as big, but a friend of mine, Marcus and Catherine Ottmers, came out and they did a project to on this landowner on the Colorado River, I believe, to help slow the water down. So using all on-site materials, they chipped up some of the downed debris, they moved some rocks, they put them perfectly level using a laser level. And what you end up getting is the vegetation to come back in these little strips, just like the microdetritus berms. But the vegetation is what's really going to help filter and biologically filter to help keep some of those ashes and some of that charcoal and some of the, dirt that is no longer held by the vegetation, keep that from hitting our rivers and becoming a water quality problem. And this is not new. Native Americans have been doing this for thousands of years. This is an ancient German technique called hugelkultur. You can see when you're doing trimming, instead of burning this brush, you can lay it down and you can actually cover it with soil, and all of the stored carbon and all of the stored energy that you can release by lighting one of these logs in your fireplace and warming your toes in a cold winter day, instead of releasing all that stored energy in a 24-hour burn, it can slowly be released and act like a battery to recharge the next generation of plants and the next generation of trees. And after maybe 20, 25 years, if you're using juniper branches, maybe 125 years, that material ends up feeding the next generation of plants, and you keep your carbon in the ground where it's an asset and out of the atmosphere where it's a liability. Also, when you're doing that, there's all sorts of tiny little gaps where the soil just doesn't go, and that makes incredible amphibian habitat. So in lots of places where I've done this around the state, the amphibian numbers just go through the roof. Did a little bit of this work in Bastrop State Park when I was a park specialist there back in 2005. I am not an expert on the Houston toad, but I studied amphibian biology in my master's degree. So I know that providing these niches and these habitats are beneficial. I haven't found any data specifically on the Houston toad, but there's definitely things you can do in your region where we have this really remarkable toad species to help keep that population alive and healthy and thriving. Other things you can do is you can install a residential rain garden. There's tons of information on how to do that. I want to highlight an example that one of my friends gave me in his backyard bioswale. So he has water running off of his house. The land is sloping down. There's an alley behind his house, but he dug this trench and to catch some of the runoff and gravity irrigate all of his crops. But what I think is interesting is look at this. Can you see a difference in color here? See how it's darker green and looks healthier? He's not like putting a hose over the fence and irrigating the alley. What that is that's what's called a swale plume. There's an amazing 98-second video if you look for swale plume on the internet. And that's basically where this flooding liability gets turned into a groundwater asset and it plumes out and acts as free gravity-powered irrigation to landscape. And you can do that all over the place. This is a project I did when I was the aquifer recharge specialist for Joint Base San Antonio. This is in front of the Quadrangle, a fairly historic site in San Antonio. We installed 10 rain gardens in front of the Quadrangle, and we did it using mainly Girl Scout help. Out at Camp Bullis, which is 28,000 acres of land right north of San Antonio and over the recharge zone, we installed hike and bike trails, but we put them on contour with these raised mulch humps. In many cases, any place where you can put it on contour, that raised hump helped act like a mega detritus berm and slow down a lot of water. Again, we're turning flooding liabilities into groundwater assets, and we're doing it with Cub Scout work crews. We also did projects with engineers and future engineers. These are some folks at Joint Base San Antonio, and we spread wildflower seeds on all of these different colored bioswales. This was all done above grade because the military is very touchy about doing any sort of digging. But after about 1 year, when the wildflowers came, we provided amazing pollinator habitat. So this is habitat for your birds and your bees and your toads and your butterflies and the monarchs. And there's ways that if you start teaming with nature, you can be stacking all these different functions. So it's not just water quality improvement. It's not just flood mitigation. It's an outdoor learning classroom. You can install these with a bunch of sweaty hippies in Austin, which we did at the Festival Beach Food Forest. So this group of folks is right at the northeast corner of I-35 and the Colorado River. They took, I think, about an acre, maybe 2 acres of land that was just mowed flat, and they made a food forest to help address food insecurity. This same group has done work in dozens and dozens of places across Central Texas. This top one is at a school in San Marcos. They're turning a flooding liability into a groundwater asset. I believe this is Travis Elementary School in Austin. This group came out and dug a swale to catch all of the water out of their downspouts. This water soaks in and basically gravity irrigates all the plants they planted. So now you have this massive growth of fruit trees. It's turning into a food forest. They planted sweet potatoes in there. There's a bunch of native pollinator plants. So instead of having to go all the way to the zoo or going on a long field trip to go learn about pollinators or butterflies or the whole metamorphosis process of butterflies, they can literally walk out the door and they can see this outdoor living classroom every single day. And those students are learning a phenomenal amount about water and plants and where their food comes from. There's another school, I don't have a slide of it, but there's a school in Wimberley that's embracing this one water concept, which I think is phenomenal because we really do need to help educate our next generation of voters on how important water is to the state. Here's an example in a more urban setting. You can see that water would normally just run right down this curb and run and cause flooding problems in this whole neighborhood. But some of the same groups that did the Festival Beach Food Forest came out here. We did some curb cuts. We're inviting water into this community park. It's being filtered through Eastern Gamma Grass and Maximilian Sunflower, which are 2 amazing riparian plants that help biologically filter that water. And again, Green Spaces Alliance and the San Antonio River Authority have been doing this type of green infrastructure and low impact development in Central Texas for a long time, and they are just an absolute wealth of knowledge. Here's some more projects. This is in Spicewood, Texas. Again, this is in your watershed. These projects, again, we have a before and after. They were funded by a USDA Young Farmers Grant. They installed these contour terraces similar to what the Civilian Conservation Corps did to help mitigate the Dust Bowl and the Depression. Many of those structures are still functional after 80 to 90 years, and they're continuing to turn a flooding liability into a groundwater asset. So remember what the 4 main things are for plants, right? There's plenty of sunlight here, plenty of carbon dioxide. There's a lot more water than there used to be. But if you look at the soil still is it's not very organic. It needs some help. But by storing the water here, it unlocks the growth potential of this land. And within 1 year, it's covered in pollinator habitat, and that flooding liability is turning into fruit trees and groundwater. Here's another example about an hour away from Smithville. This is in Maxwell, Texas. I'm pretty sure this drains into Plum Creek and into the San Marcos River and not into the Colorado River. However, this project does something very similar. It was funded by a USDA Young Farmers Grant, and they're basically mitigating drought and flooding 1 scoop at a time. I'm going to highlight some stuff on this project here in a minute, but project being dug, the first major rain that helps slow spread sink water in the landscape. It did actually hold water a little bit longer than we wanted for the first year or so. But as the grasses started getting established and those root systems broke up that heavy clay soil, it now infiltrates pretty darn quick. This is about a 12-acre project, and it turns flooding liabilities into all sorts of fruit trees. I want to highlight here one other thing that I think is really important. I want you to look at this gap. There's a gap here, there's a gap there, there's a gap here, there's a gap there, there's a gap there. All of these gaps, you can see the existing ground and grass. They're all at grade. So the water is only stored in basically a ditch that you dig into the ground. There's no opportunity for a blowout. So unlike a flood control dam, that if the dam blows out, like happened in Bastrop State Park a couple of years ago, and you have this big surge of water running downstream, which is dangerous. It's, they call them high hazard dams, and they represent a catastrophic risk. There's no opportunity for a blowout here because this diagram explains it better. All of the water is stored below grade, and we release the water, you let it flow down and run into standing water. Then it gets released over here and it flows into standing water below grade, gets released at grade and flows again into standing water. So you're basically increasing the meandering of every droplet of water before it ever makes it to the river. And if you go back and watch Kevin Anderson's talk on the rivers, those meanders are phenomenally important to the functionality of a river. And some other cool things is in your watershed, this is an example that just won last week. This just won the 2021 EPA Green Infrastructure Award. They were competing against a 5-state area, basically Texas and every state that touches Texas. And this is in the Vireo Preserve in Austin. It's part of the Balcones Canyonlands Preserve. And they took a dry, degraded caliche hilltop, and they slowed, spread, sunk, soaked, and stored water in the landscape. They planted some native plants, and they said they're already seeing increase in pollinators, increase in birds, and increase in amphibians. And I think this was only installed in the fall of 2019. In many cases, this can be done on a much larger scale. So on larger scales, they're slowing water down. They're turning that rainfall into irrigation assets for all sorts of perennial crops and fruit trees that help provide things other than corn and soybeans, which is what a lot of our farms make. Another graphic, I've used a couple of these so far, but I want to highlight, this is from a book by Brad Lancaster. It's called Water Harvesting for Drylands and Beyond. It's a phenomenal book. I would recommend it to absolutely anybody. It basically uses cartoons and line drawings to help demonstrate some really complicated topics. And even though it says it's for drylands, this type of nature-based solution works in virtually every environment on the planet. And the swale plumes, these aren't just little things that you can see in your backyard like I showed you earlier. Here's some examples where these are swales put in on contour. All these lines are on contour. All these trees are laid out on contour swales. And what you can see is as water comes down the landscape and hits one of those swales, the swale plume you can see from satellite, you know, the green here, all of these green drips or that swale plume that I showed you in the alley. And this is additional water moving through the soil profile, slowly making its way down to the river where you get those little riparian springs that help keep your river flowing in times of drought. But when you're a farmer or a rancher, green is money. Green is dollars. This ranch is way healthier in times of drought than all of his neighbors that are brown, because your cows want to eat, you know, fresh green grass. And there's billions of dollars available here in the United States. This is the EQIP program in 2021. The USDA is helping farmers by giving them about 1.8 billion in funding. And I want to highlight here, even on the main website for the EQIP program, they highlight basically contour swales, catch the water, slow it, spread it, sink it, soak it, store it, all the way down the landscape, turning flooding liabilities into groundwater assets. And trust me, this is nothing new. This is an example where Native Americans were building these structures by hand using digging sticks in a 35-pound wicker basket, throwing dirt on their back and carrying it up to the berm and dumping it. So this system is over 3.5 miles. There's 131 ponds. It's 2,000 years old. However, these systems are still functioning today after 1,800 years of total human neglect. So these kind of practices are a good investment. They're good for the economy. They're good for the environment. They're good for human health. They're really good for the triple bottom line. They're good for people. They're good for planet, and they're good for profits. So now I want to highlight someone in your watershed, in the Pedernales River watershed, which flows into Colorado, David Bamberger. I'm sure several of you have heard of this gentleman. He changed my life. I visited his farm when I was in the Boy Scouts back in 1992, and I want to always throw recognition towards the work they're doing. You can learn more about it to watch this video, Water from Stone, and I'll highlight here, again, it's all about series. You catch the water, you catch the water, you catch the water all the way down the hill. So because he didn't have the brush, he was using rocks to help slow the water down. Here's another diagram from Brad Lancaster. You do it in a series and you catch the water, catch the water, catch the water, catch the water as it goes down the hill. So when I was in high school, we had a little place back in Bamberger, Texas, and I went to David Bamberger's and I was like, man, this is amazing, and I could do this on my own land. So I was mitigating flooding with a chainsaw. I went out and I lollipopped up the junipers. I took all these lower branches off. In the backstrap area, you can take some of the understory under the pines. You might want to be thinning out like your Ilex vomitoria or your possum haw or whatever the local name is for it. But your understory shrubs, you can lay them down on contour using a laser level. And later on, if you don't want them to burn, you can cover them with sand. You can cover them with soil. In this particular case, I went to the city of San Antonio and I was collecting all of this Christmas tree mulch, and I covered all the brush up with Christmas tree mulch, which basically is clogging the filter. And I've been enthralled with this ever since 1992 when I visited David Bamberger's place. So again, props to him. That has led me to work on projects on a larger and larger scale. This right here is a blue Honda Accord for scale. There's an erosive creek. This is up near Fredericksburg. It's in the Pedernales River watershed. This is a 40-acre. They were doing 100 acres of clearing through the Texas State Soil and Water brush management program. In a lot of cases, they would bulldoze and burn and send that carbon dioxide in the atmosphere and not leave any structure on the land to slow spread and sink water in the ground. So on the 40 acres that I had, the opportunity to work on, we did trim the junipers because that what was required by the state. They paid this landowner, I think, $300 an acre for clearing. But you can see these brown lines in the landscape. So there's a brown line of juniper brush. 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 And if you think about that, imagine the creek, this creek being the midrib of a leaf and all of these being the side veins. So just like what a leaf does from the midrib, taking that water, instead of concentrating it like a river system does, a leaf concentrates it in its root system, brings it up, branches it out, and all these branches, and starts dividing up this water flow. And even in the leaves, it takes the nutrients and it takes the water and it basically takes it out of the main channel and it divvies it off and it slows it, spreads it, sinks it out into this whole leaf landscape. And you can use the same patterning using Beaver biomimicry or leaf biomimicry or whatever you want to call it to help rehydrate your uplands. I did a lot of work after storms, and what is there after storms like Hurricane Harvey? There's typically a phenomenal amount of wood mulch. Right now, most of our communities have more wood mulch than they know what to do with. You can get it for free, and you can use that wood mulch to turn it into wildflowers. So again, I'm going to go back to that concept of carbon. Carbon in the ground helps build your soil, and a healthy soil makes for healthy pollinator plants, and those pollinator plants provide all sorts of goodies for everything. And just like that earlier picture, this is the same day, both sides of the road, two sides of the same road at the same time. Both were planted with pollinator plants, but this one, there's nothing to slow the water down. There's not a lot of organic matter. The water rushes right off. 40 feet away, with the mulch and with some bioswales, this water was captured and it turned into unbelievable pollinator abundance. So again, it's the environment of the mine that makes a difference. Which side of the fence do you think is healthier? Now I'm going to talk about a project we did for Joint Base San Antonio. This is Camp Bullis military reservation. If you Google Camp Bullis and look it up on a map, try to find this runway. It's right at Cibolo Creek. And if you look immediately below that, you'll see what we call Mercedes Hill. We did 3 different treatments. We did this contour treatment. We did basically a bulldoze and burn treatment. And then we did a mulch everything in place treatment. I'm going to talk about the contour beaver biomimicry treatment. We laid out these level contours of mulch. We did this over a 2,800 acre area. About 800 to 1,000 acres got this contour treatment. You can see these LiDAR lines. These are our contour lines. So you can see the lines of mulch are pretty darn even with the contour lines. So as water wants to escape the top of the hill, it escapes and you catch it in a microdetritus berm, and you catch it again, and you catch it again, and you catch it, and you catch it, and you catch it, and you catch it all the way down the hill. This particular project has had virtually zero runoff since 2010. The mulch paths are about 18 feet wide and were initially about 18 inches deep. They're being used as roads for troop activity. As the water tries to come down, it can't escape, so it soaks into this porous limestone rock in our karst aquifer systems. It helps the plants grow. In some cases, these plants were 300% larger and healthier than the plants just a few feet further away from these brush berms. And I want to highlight that this project on the 2,800 acres, it's certainly helping improve the habitat. There's been almost no runoff, and that runoff, the water that's soaking in is likely more water going into the groundwater system than this whole all of Camp Bullis pumps on an average annual basis. So there's certainly ways that we can turn flooding liabilities into groundwater assets, and it's all between our ears. It's how we manage the land. But unfortunately, not many people do this, right? This is what most people see. They push all the brush up into a brush pile. They light it up on fire. The carbon is not going into the soil where you need it. It's going in the atmosphere where we don't really need it. And you're degrading all the structure that could be used as habitat. And you're letting the water rush off really fast. You're not soaking that carbon into the ground, and you're not helping protect the river flow, and you're not helping protect the spring flow. Now let's talk, just switching gears slightly, but we're still talking about carbon. Let's talk about opportunities for funding. So there's a group here, the Texas Coastal Exchange. They're actually paying, they're currently paying Texas landowners with wetlands in these coastal counties to protect those wetland areas, to act like a biological filter for water going out to the Gulf Coast, which protects our coastal fisheries. But it also, that wetland along the coast acts like a buffer for storm surge. So as the storm tries to slam into Texas, these areas that are undeveloped, you don't have the houses you have to rebuild. The wetland area actually buffers some of that, and the funding's coming from groups like Valero Energy or Sprint Waste or dozens of other companies. Shell Oil, for example, pledged to sequester 120 million tons annually. In most cases, farmers that are focused on regenerative ag can sequester about 1 ton per year, 1 ton of carbon per year with good practices. So this Shell Oil, just this one Fortune 500 company, is 3, 4, or 5 times the size of your Colorado River Basin. So if you can attract private sector investment, say, hey, we've got these great projects here in the Colorado River Basin, you can bring private sector funding in there to help you protect your river. And now going up into the uplands, there's all sorts of groups paying landowners for carbon. There's this out of the Rice Baker Institute. It's something called B Carbon, and they're paying landowners for sequestering carbon in mainly ranches. Soil Works is based out of San Antonio. NORI is a group, I think it's out of Washington State. There's this Vera group. All of these people are currently paying landowners across the United States to do those soil health practices that help suck carbon dioxide into the soil. What you're not hearing as much, but I'm sure you will, is the tie between carbon and water is I mean, they cannot be separated. Carbon and water cannot be separated. So if you do work to help your land become a better sponge by making the soil more carbon rich, you're going to help recharge these aquifers of Texas. And one I'm going to focus on a little bit because I grew up in San Antonio is the Edwards Aquifer. So this green area is 3.4 million acres. It is specifically not in the Colorado River Basin, and I won't go into much detail as to why that is. But water that soaks into the recharge zone here does help the Colorado River Basin because some of this water comes out in Barton Springs. Cities like San Antonio understand they rely on this groundwater supply. They rely on the springs that San Antonio was founded at. And basically, they've been putting their money where their mouth is since 2000 to protect all of these properties along the recharge zone. I wish they would also start focusing on the contributing zone because that's basically this giant sponge that helps turn flooding liabilities and groundwater assets. So in that contributing zone, which they call the drainage area, That's an upper sponge in the hill country. The hill country are full of these micropores and karst features. So as it rains, you can help water soak into there. Then you get these water table springs like, Jacob's Well, and in some cases, Barton Springs. Most of the towns in the hill country are around some sort of spring. So you can go find them. But over the recharge zone is where the water can actually soak in and go into these deeper artesian areas. And those provide some of those larger springs that I've highlighted in like Del Rio and San Antonio and Comal and San Marcos and so forth. But the groundwater is just an incredibly valuable resource for Texas. And there's all these different groups right now spending money in Texas. FEMA just gave since Harvey, FEMA gave $4.3 billion to the Texas Department of Emergency Management, and they're looking for nature-based solutions. The HUD, the Housing and Urban Development, gave another $4.3 billion to the General Land Office, and the General Land Office is absolutely looking for nature-based solutions, and I'll have a quote here at my next slide. Rebuild by Design is something that spun off of these HUD funds. The Army Corps of Engineers have literally trademarked engineering with nature, and they're trying to work with natural processes to help keep our rivers clean and help keep the sediments out of the rivers, because they spend billions and billions and billions of dollars annually trying to dredge some of the rivers out to keep them open for navigation. And here's a map of all of the Texas counties that are available. Well, not all of them, some of the Texas counties that are available for some of that $4.3 billion from HUD going through the General Land Office. And I want to highlight something that was a presentation given at the Texas Land Trust Council in February 2020. Josh Oyer from the GLO said, projects that provide co-benefits to ecological and infrastructure protection needs end up being most suitable for prioritization in our plan. So basically what he's saying, if you apply for money through the GLO and you apply for funding that helps your natural resources, your natural infrastructure, as well as your bridges and your houses and your built infrastructure, those projects are going to receive priority for some of that 4.3 something billion dollars of funding. NOAA has this U.S. Climate Resilience Toolkit, which is pretty amazing. FEMA is really focused on nature-based solutions. They just released some funding for 2021. They released a RFP for funding for 2021. Last year it was $500 million. This year it's a little bit over $1 billion. So you can see they're interested in that. And what they're starting to realize is that bad land management and degrading our forests, degrading our biodiversity, degrading our lands, overgrazing our grasslands, it sets up a negative feedback loop where the land gets worse and worse and worse over time. And eventually it leads to a desert. An amazing presentation on this comes from a guy named David Montgomery. If you look up Dirt, the Erosion of Civilizations by David Montgomery. He has a 60-minute talk on this that is phenomenal. And it talks about cultures throughout human history that have degraded their environmental resource, and then they couldn't grow enough food and they ended up drying up and going away. A great example of this is the Garden of Eden and the Tigris and Euphrates River. Basically the cradle of our civilization was overgrazed and went from the Garden of Eden to what's now a desert in like Syria and Iraq and Egypt. But you can restore that, and there's examples all across the world. And I'm going to end in the next two slides with this. So you can start reducing your erosion. You can build your soils. You can replant. You can bring in that biodiversity by doing slowing, spreading, sinking that water into the landscape on some of the practices that I've talked about today. Even though I'm running a little bit long here, that helps protect your river. That helps bring back the health of the ecosystem. And what people really need to start understanding, and it is the health of the ecosystem that drives the health of our economy, that drives the health of our population, that drives the health of our communities, that drives the health of our river. You have to have a healthy functioning ecosystem if you want to have a healthy economy, if you want to have healthy people, if you want to have healthy planet, and if you want to have healthy profits. This is actually an example in China. You can find it if you look for the lessons of the Loess Plateau. They took a highly degraded landscape, been degraded for thousands of years through predominantly over agriculture and overgrazing. And they did these practices and they converted a highly erosive borderline desert into a healthy, thriving forest with lots of agricultural areas and terraces to grow the different crops. They doubled the average annual income. They more than doubled, they almost tripled their net productivity and the amount of products that are coming off the land. And they basically, they brought millions of people out of poverty over an area, I think, of a couple million acres, 3-4 million acres. And I think even though this is in China and they were voluntold that they have to do this, in Texas, I think when you start showing the landowners what kind of benefits you can get to your own private land and into the bottom line and into your pocketbook, I think people are going to start moving this way. And I really think these programs through the federal government, as well as these private sector programs and carbon funding to help act as a carrot to help farmers in Texas be more eco-friendly and protect their habitat and restore their soils. We're really going to see a lot of benefits of that going forward. So if any of you guys are interested in connecting on any of these topics, I am planning to be available for your question and answer session. You can also reach out to me. I'd love to help any folks. I've had the reason I'm here is Jill is working on grants, bringing in all sorts of grants to the Smithville community and doing a fantastic job at that. And I'm trying to help do that across the state. So if you have interest, I'd love to connect with you. And that's the end of my presentation. I'm going to stop sharing and give it back over to Jill.
Wow, thank you, Brian. That was fantastic. Oh my gosh, that was just a real wealth of information, and kind of very a lot of it. So yeah, I'm really glad we recorded that. We'll be able to go back and review that a couple of times. Oh my gosh, just the idea of the beaver population and how that so dramatically changed the rivers and the landscape overall. I mean, from very basic information like that into all of that, all of the strategies that we can use now. Oh my gosh, it's all so exciting, I have to say. I hope that people are going to look for the carbon cowboys, and that they'll look into doing these filter strips and then riparian buffers, protecting our water quality and increasing the carbon in the soil rather than in the air. I mean, all of this is so amazing. The slow it, spread it, sink it, soak it, store it. I think that's something we all should start saying. It's even more than the 3 E's, right? So we've got to start making sure people understand all of that kind of thing. And with your information on the grants as well, being the grants administrator here at the City of Smithville, I'd be more than happy to start help anybody who wants to look into that. And again, like Brian said, if you are interested in the nature-based solutions and more information about this topic, we will be having that presentation. We'll have 2 live panels on this program. So one will be August 31st at 6 o'clock. The other will be September 2nd also at 6 o'clock. We'll be sending out Zoom links and whatever, YouTube or however we're gonna share it and make sure that everybody's available for that. And I wanted to share my screen real briefly and just say thank you to our EcoFest sponsors. Our title sponsor is WJC Constructors. We have a number of other sponsors you can see up here on the screen. So grateful to all of them for all of their help and their support in Smithville. We're going to be very happy. We're very grateful and happy for Brian, for you to be here, for all of the viewers to be here, and for all of our other panelists as well that you'll be seeing on this program. And thank you again to the viewer for being here. We really appreciate all that y'all do. And I'm going to stop sharing my screen now. Stop sharing. I think that's it. Thank you very much. And I'm going to stop recording. Thank you.
Thank you.